Hello, we're back to Energy 101. It's still looking at energy sources. This time we're going to look at a renewable fuel, and that being ethanol. Ethanol is an energy source, and it is a significant energy source. As we saw last time, it makes up about 5% of our transportation fuel, and is 5% is a significant number, and does substitute in gasoline on almost a one-to-one basis, although we'll talk about that a little more later, with gasoline. So a gallon of ethanol in your tank mixed with a gallon of gasoline would displace a gallon of gasoline. That's an oversimplification, but it is a direct substitute. But how much of the ethanol are we using? Where does it come from? What are its characteristics? You hear a lot of various things about ethanol, good and bad. So let's look at some of them. Well, the U.S. ethanol that is produced today is all comes from corn in any quantity of significance at all. When you talk about ethanol in the U.S., we're talking about corn ethanol. And you hear other terms such as cellulosic ethanol. We currently do not get any significant ethanol from cellulosic material, which I'll refer to later. But at the current time, 40% of the corn grown in the U.S. goes to ethanol fuel. That's a pretty astounding number, that 40% of the corn grown. And it really, ethanol as the demand for corn is a competitor to food because, of course, one of the big users of corn is raising of beef cattle and hogs and things and pigs and pork, and so that the price of anything at your grocery store that's made from corn has gone up in price because 40% of the demand for corn as a whole goes toward ethanol, which is not a food product. So that's one issue with corn ethanol. Again, cellulosic ethanol, which we hope to get to here shortly in the future regarding in the U.S. Production of ethanol, is another ballgame. By the way, Brazil, you hear Brazil has started back in the early 80s producing ethanol from sugarcane. And they have a long growing season. They have inexpensive labor in order to harvest it and deal with the handling of it. So they are getting a substantial amount of their transportation fuels from ethanol, and even are exporting it some around the world. So what has happened to ethanol production in the past from period 1980 to current? So over here we see that in 1980 the production of ethanol was very low. It was down at 0.02 or so million barrels per day, 0.02, 20,000 barrels per day, very, very low. And it gradually went up as we moved down to 2001, 2002, and at this point you started having subsidies of approximately 50 cents a gallon for the production of ethanol to go into gasoline. And since then, it has skyrocketed, and that's basically due not only to the 50 cents a gallon subsidy, but it also is due to mandates to blend gasoline that's put into automobiles with 10% ethanol. And so all cars now, essentially all, not 100%, but almost 100% of the gasoline that you get at the corner filling station contains 10% ethanol. And most of that is by mandate. They mandate every year so many gallons of ethanol must be used in blending with gasoline. And that has driven the production of ethanol. At the end of 2011, the approximately 50 cents a gallon subsidy for ethanol blended with gasoline went away, which has stayed for, 15, 20 years at least. but that's now gone. But the mandate to blend a certain number of gallons a year has continued to increase, and therefore the production of ethanol is now almost 1,000,000 barrels a day. And I've put everything pretty much on the same units here, and that is millions of barrels per day when we're talking about natural gas liquids or crude oil or ethanol, barrels per day in the production. So remember, we're producing in this country about 6 million barrels a day of oil, and we're producing almost 1,000,000 barrels per day of ethanol. So that's a pretty good chunk, and it does substitute almost on a one-to-one basis and displace the use of crude oil, and so that we don't have to import that 1,000,000 barrels a day from overseas or outside the country. So it does reduce crude oil consumption on almost a one-to-one basis, but not quite. How is ethanol used in our transportation fleet? Well, mostly it's with 10% ethanol and 90% gasoline. All cars are now approved for use of 10% ethanol, and even cars produced since 2000 have just recently been approved retroactively for 15% ethanol, because with the recession and the decreased gasoline sales, there wasn't enough gasoline being used at 10% ethanol concentration to use all the ethanol that was mandated to be blended. But another way that we use ethanol in our transportation vehicles is E85. E85 is 85% ethanol, 15% gasoline. And it can only be used in flex fuel vehicles. They're special vehicles. There's some mileage boost that you get if the manufacturer of automobiles make them flex fuel. It only costs the manufacturer $100 or $200 to make cars that they produce, the Chevrolets, Fords, Cadillacs, Mercedes, BMWs, whatever they might be, to convert them to where they can use either 100% gasoline or 15% gasoline and 85% ethanol. You can put anything in the tank and detectors detect what it is and make all the adjustments in the fuel distribution system that the car runs fine. There are approximately 10 million flex fuel vehicles on the road. That's out of a couple 100 million vehicles that are on the road. So about 5% of them are already flex fuel vehicles, and about 1 million a year, close to it, are being added to our fleet on the road today. So that's the way the ethanol is used, and the reason it makes up about 5% of our total transportation fuel. And that's shown here as we saw this pie chart before. The yellow is the 5% ethanol, 72% gasoline, 23% diesel. By the way, that 72% gasoline includes things like aviation fuel, and that we don't blend ethanol with aviation fuel. It's because of the unique characteristics of aircraft engines. Now, I've mentioned a couple times that a gallon of ethanol displaces and can displace approximately a gallon of oil or gasoline. Well, that's not really true as we look at it a little closer. And the reason is that if I burn a gallon of ethanol, I get about 2/3 of the amount of heat released as I get from a gallon of gasoline. So that means when I go to the fuel station and corner gasoline station and pump 90% ethanol and 90% gasoline and 10% ethanol, I cut my gas mileage a little bit compared to 100% gasoline. And take for an example, a 30 miles per gallon auto that will get 30 miles per gallon on 100% gasoline will get about 28 miles per gallon on 10% ethanol fuel. That exclamation point should be a 1. Apologize for the typo here. That's 10%. 10% ethanol. So ethanol you'll use more gallons of ethanol to go the same distance than you will for gasoline. So there's not quite a one-to-one energy balance there. Well, what percent then is that of the, looking at liquid petroleum, total liquid petroleum, which is a term that is used a lot, and you see it in the press and in newspaper articles and TV media presentations, that they talk about petroleum. So petroleum are the liquids, but then they are made up of ethanol, natural gas liquids that we talked about last time, and oil. Now, how does the production compare? We looked at before the production of natural gas liquids, which is the red here, that's added to oil that's in the blue down here. So this is about the 6 million barrels per day. The natural gas liquids is about 2 million barrels per day, and this is about 6, and the ethanol is about 1 million barrels per day. So, and you can see that these two here in particular, and as well as crude oil, with the Bakken discovery and things, have increased production significantly since 2008. So if we add all of them together, we're up here in 2008 we were about 7.5, and now we're about 8.7 or so. So that's a significant increase, 7.5 to 8.3 or 4, 8.7 or so. So things are improving in trend when we add all those together. But we talked about last time in natural gas liquids, they do not substitute on a one-to-one basis for oil. Ethanol does a better job of it, but it substitutes on about a barrel of ethanol substitutes for about 2/3 barrel of gasoline. So we have to be careful about that. Okay, you hear a lot about the term ethanol energy balance for ethanol produced from corn. What we're talking about there is how much fossil fuel does it take to make a ethanol that has 1 unit of energy in it. Make the unit anything you want. Make it 1 million barrels of ethanol, you can make it 1 barrel of ethanol or 1 gallon of ethanol. It requires 0.8 units of fossil fuels to make enough energy in ethanol to produce 1 unit of the ethanol. So it's only about 20% gain. But the fossil fuels aren't oil in general. They're primarily natural gas and coal. So in some ways, it's like we're transforming natural gas and coal into a transportation fuel, which is not typically used for transportation. So that's one way to view it, because it takes about 0.8 equivalent barrels of natural gas and coal, equivalent on an energy basis, to make 1 equivalent unit of corn ethanol. So it's not a very renewable fuel in that regard, because we're only gaining about 0.2 units for every 1 unit of ethanol we produce as far as gaining in the energy produced. This is shown here with the corn ethanol, that this is percent of ethanol energy output, how much energy input has to go in to produce the ethanol. That's fossil fuel inputs, and here's the yellow is coal, the red is natural gas, other is green, and oil is blue. Now, the kind of things that these are used for instance, is the tractors that plow the fields and pick the corn use petroleum, use diesel fuel or gasoline, and in the processing of corn to ethanol, it takes a lot of natural gas, because you get a lot of water mixed with the ethanol, and you have to increase the concentration to about 99% pure ethanol and 1% water, and it comes out of At one point, it comes out at about 80% water and 20% ethanol. So we have to distill it down. That takes a lot of natural gas. So those are kind of ways that we have to use fossil fuels to produce ethanol, corn ethanol that is. And if you compare that with cellulosic ethanol, that we can certainly do it in the laboratory. We can get it, for instance, wood, was like wood alcohol that was invented, so to speak, and the process was invented in 1898. It takes very little fossil fuel energy and energy input in order to produce a full unit of ethanol energy in when we burn it. So cellulosic ethanol, which wood is just one example of it, would be much, much better from an energy balance viewpoint. Okay, next time we'll look at some of the energy independence, what all this means about energy independence. You hear a lot about oil independence, energy independence, so we'll look at those topics now that we've covered all the significant fossil fuel production that we have: coal, oil, gas, natural gas liquids, and ethanol. Thank you. See you next time.